Okay students, today in this video let us start complex numbers for your IIT preparation. Clear? So before going to complex numbers, let us study how complex numbers were introduced. Clear? And next let us go for what is the relationship between complex numbers and real numbers. Then we shall move for the definition of complex number. So first let us see how the complex numbers were introduced. We know how to simplify x square minus 1. What is the solution of x square minus 1? X minus 1 into x plus 1. No problem. We know how to simplify x minus 1 whole square. That is x square plus 1 minus 2x. I think you are getting my point. Now let us go for how to simplify x square plus 1 equal to 0. If you choose your real number set R for x belongs to real numbers R, in this x square plus 1 equal to 0, you can't find the solution. Why? Because say this, x square will be equal to minus 1. Are you getting my point? If I simplify x square plus 1 equal to 0, it implies x square equal to minus 1. So then what is x? X will be equal to root of minus 1. So we know that root of minus 1 not belongs to R, that is your real number set. So for now what we have to do, that means this root of minus 1 is nothing but your I, that is imaginary root. We call it as imaginary root because it doesn't exist in real number set. Clear? So if we simplify x square plus 1 equal to 0, now we got x equal to root of minus 1. So that's why we introduce our new element I, that is iota. I is called as iota. The first person to use this was Euler. Euler introduced this I as calling it as iota. Clear? So make sure that we can simplify this in real numbers. We can simplify this in real numbers, but we can't simplify this in real numbers. That's why we introduced our new set, that is complex numbers. Clear? We introduce complex numbers because of solving this type of algebraic equation. That's how we gone through iota, that is nothing but I equal to root of minus 1. Clear? Okay. Next, let us see the relationship between now let us see relationship between real number set and complex number set. As we all know, this is natural number set. This will be integer set. This will be your rationals. Next, this will be your real numbers. Clear? Next, if we go for complex, this set is going to be complex numbers. That means natural number is a subset of complex, integer is also a subset of complex, rationals are also a subset of complex, real numbers are also a subset of complex numbers. So complex number set involves all the type of real numbers. This is what the relationship between complex numbers and real numbers, that is R will be an subset of complex number. What is the meaning of R is a subset of complex number? Every real number is a complex number, but every complex need not be real. That is what real number set is, a subset of complex number set. Make note that is every real number is in a complex number, but every complex need not be an real number. Clear? So in the next examples you are going to be very more clear about this statement, that is every real is complex, but every complex need not be real number. Okay, next let us go for, now let us see the definition of complex number, that is a number in the form of a number in the form of a plus ib, or you can write it as x plus iy, where order pair a comma b or order pair x comma y are in real numbers, Clear? Here we know that I equal to root of minus 1. Are you getting my point? A number in the form of a plus ib or x plus iy are known as complex numbers, where a and b, x and y are your real numbers and I is your imaginary root, that is I equal to root of minus 1. I think you are getting what I am saying. Already I have explained what is I. What is I here? I is root of minus 1, that is imaginary root. This imaginary root is just because we did not solve x square plus 1 equal to 0 previously, which I have explained. Clear? So this I is also called as iota, where I is equal to root of minus 1. So please remember that complex number will be in the form of a plus ib, where a and b are real numbers. Also x and y are real numbers. I is your imaginary root, that is I equal to root of minus 1. Okay students, from this let us write some notes. That is, first one, a is real part of your complex number. A is real part of your complex number. Second one, b is imaginary part. B is imaginary part of your complex number. That is, a is real part of complex number, b is imaginary part of complex number. That means complex number has two parts. One is real part and another one is imaginary part. So real part will be a and imaginary part will be b. But a and b are real numbers, no problem. But in that, a is a real part, b is imaginary part, because b is present with iota. Clear? So a is purely real, b is present with iota, so that's why we call b is an imaginary part. Clear? Every complex number has two parts. One is real part, another one is imaginary part. Real part is a, imaginary part is b. So here you can see that real part is x, imaginary part is y. Are you clear? So the definition of complex number says that the number in the form of a plus ib, where a and b are the real numbers, I is equal to root of minus 1, which is called as iota. And the notes of that definition is that a is real part and b is imaginary part. That you have to make a note. Okay students, now let us go for iota. Let us see the powers of iota. That is, we all know I equal to root of minus 1. It will be very simple that I square will be minus 1. Now see what is I cube. I cube will be what? See, you can write it as I square into I. That means minus 1 into I. That is minus I. I think you got what is I cube. I cube can be written as I square into I. So now I square is minus 1. Minus 1 into I. It will be minus I. So keenly observe what is I raised to 4. Very, very important. What is I raised to 4? I square into I square. What is I square? Minus 1. What is I square? Minus 1. Minus 1 into minus 1. It is plus 1. So it is very, very important, my dear students. So many number of times they have asked the problems on just the powers of I. Calculating the powers of I. I is root of minus 1. I square is minus 1. I cube is minus I to the power of 4 is 1. So make a note that I to the power of 4k will be always equal to 1. I to the power of 4k will be always equal to 1, and I to the power of 4k plus a can be written as I to the power of 4k into I raised to a. Clear? That is, I to the power of 4k plus a can be written as I to the power of 4k into I raised to a. I think here you know that it will be equal to I raised to a, because I to the power of 4k is 1. Clear? Okay. This is what the powers of iota says. Let us see some examples. First you make clear that I square is minus 1, I is root of minus 1, I cube is minus I raised to 4 is 1, I to the power of 4k is 1, I to the power of 4k plus a is I raised to a. Clear? Now let us look at some examples. What is I raised to 5? It will be I to the power of 4 plus 1. That means I to the power of 4 into I. So it will be equal to I. Because I to the power of 4 is 1. 1 into I will be I. What is I to the power of 7? I to the power of 4 plus 3. Again it will be I to the power of 4. I to the power of 3. So I to the power of 4 is 1 into I to the power of 3 is I to the power of 3. Now what is I to the power of 3? I square into I. I square is minus 1. So this will be minus I. So I to the power of 7 is minus I. Next, what is I to the power of 9? Very, very important. What is I to the power of 9? I to the power of 4 into 2 plus 1. I think you know this in the form of AB plus R or AQ plus R, Euclidean algorithm. Clear? From the Euclidean algorithms you can write it as 4 into 2 plus 1, that is 9. So this will be 1 into I. So answer will be I. Clear? Now what is I to the power of 14? Again same. I to the power of 4 into 3 plus 2. So that is I square. That will be equal to minus 1. This is how you have to simplify the powers of iota. That is I equal to root of minus 1. I think you are getting my points which I am explaining one by one. Clear? So this is what iota powers. So now let us look at problem number 1. That is root of minus 2 into root of minus 3 equal to what? Clear? Option A, root of 6. Option B, minus root of 6. Option C, I into root 6. Option D, none of this. So what is your answer? Let us see. From your simplifications you can write it as root of minus 1 into root of minus 1. One from root 2, another one from root 3 into root 2 into root 3. So we know that this is I. We know that this is I. I into I square this will be root 6 and I square is minus 1 minus root 6. Clear? So here minus root 6 is your answer. Please make note that this can be written as minus root 1 into root 2 minus root 3 can be written as minus root 1 into root 3. Clear? So this is I, this is also I into I will be I square into root 6, I square is minus into root 6. So that from this we can say that minus root 2 into minus root 3 is minus root 6. Okay. Let us go for the second one. Now let us go for problem number 2. That is, which of the following is false? Which of the following is false means we already know that I to the power of 4n is equal to 1. We know this. I to the power of 4n minus 1. That means I to the power of 4n into I to the power of minus 1. So that is 1 into 1 by I. So now how can you write this? That is nothing but 1 by I minus I minus I divided by I into I square. I square is minus 1 into 1 plus 1. So this will be minus I. So now you got your answer. This is false because this is false because I to the power of 4n minus 1 will be equal to minus I, but they have given only I. For that reason I to the power of 4n minus 1 is your false. That means option B is correct. Option B is correct. This is true. This is true. This is also true. Clear? So option B is false here. I to the power of 4n minus 1 is equal to I. That particular term is false. Okay, now let us go for the next problem. That is problem number 4. 1 plus I square is minus 1. I cube is minus I raised to 6. I raised to 6 means I raised to 4 in 4 plus 2. I raised to 4 is 1. I square will be minus 1. Minus into minus, this is plus 1. I to the power of 8 is 1 because here 8 is multiple of 4. 1 as it is I square minus 1 I cube minus I raised to 6 means I raised to 4 plus 2. So that is plus 1 plus 1. Clear? Minus into minus it will be plus here. So plus 1 minus 1 cancelled. Answer will be 2 minus I. So your answer is 2 minus I for problem number 4. Okay. Let us go for 5. Value of 1 plus I to the power of value of 1 plus I to the power of 5 into 1 minus I to the power of 5. Option A 0, option B 1, option C minus 32, option D 32. So this is what your question here. Already you know that A plus B, A minus B will be in the form of A square minus B square to the power of 5. I square is minus 1. So minus into minus this will be plus. So 1 plus 1 will be 2. 2 to the power of 5 is 32. So 32 is your correct answer for problem number 5. Okay students, now let us go for problem number 6, that is given as in this form. So from this you say that I can take I to the power of 584 common. So I to the power of 584 is common. Then what are the remaining things here? I to the power of 584 means I to the power of 8 Next, I to the power of 6, I to the power of 4 plus I to the power of 2 plus 1 divided by, from this you take I to the power of 574 common. So what you are going to have? I to the power of 8 plus I to the power of 6 plus I to the power of 4 plus I to the power of 2 plus 1 minus 1 as it is. Clear? So clearly you can see that this term and this term will get cancelled. Here I to the power of 84 divided by I to the power of 74. How can you write this? I to the power of 10 you can write. This term you can write it as I to the power of 10 minus 1. Again I to the power of 10 means what? I to the power of 4 into 2 plus 2. I square, that is minus 1. Minus 1 into minus 1 will be equal to minus 2. I think what I am explaining you are going through. Clear? I to the power of 10 means I to the power of 4 into 2 plus 2. I to the power of 4 into 2 will be 1 multiplied with I to the power of 2 will be minus 1. So minus 1 minus 1 you are going to have minus 2. I think you got what is your answer. Answer is minus 2. Clear? Okay. Okay students, now let us go for problem number 7. What is problem number 7? The imaginary part of I to the power of I. They are asking the imaginary part of I to the power of I. Before solving this, you must know this particular formula. Log of x plus iy equal to log of root of x square plus y square plus I into tan inverse of y by x. If you know that formula, it will be very simple. So let us take a equal to I to the power of I. So if a to the power a equal to I to the power of I, take log on both sides. What it will be? Log a equal to I log I. It will be in the form of I log I. So this is equal to I to the power of log of 0 plus I. Say this. Clear? This can be written as log of 0 plus I. So now you use this formula, that is log of x plus iy equal to log of root of x square plus y square plus I into tan inverse of y by x. So I equal to, if I apply this, x is 0, y is 1. X is 0, y is 1. So root of x square plus y square will be 0 plus. Next, I into tan inverse of y by x. Y value is 1, x value is 0. So 1 by 0 will be infinity. Tan inverse of infinity will be pi by 2. Clear students? So that is I as it is log of I. For that you must know this formula, log of root of x square plus y square. Here x term is 0, y term is 1. Log of root of x square plus y square will be log of root 1, that is 0. Here tan inverse of y by x, y is 1, x is 0. So tan inverse of 1 by 0 will be tan inverse of infinity. So tan inverse of infinity is pi by 2. So now I into I will be I square, that is minus 1. So answer is minus 2, that is equal to log A. If I take log on this side, what you are going to get? A equal to e to the power of minus pi by 2. So you are going to get e to the power of minus pi by 2 equal to A. Then what is your imaginary part? So see here, this is 0 plus I. You can write it as 0 plus I. So therefore your imaginary part is 0. Your imaginary part is 0 for this particular problem. Very most of the time asked in your exams, that is Karnataka CET, they have asked for 1 year, that is 2007. So imaginary part is 0. The imaginary part of I to the power of I is 0. Now let us go for question number 8. That is, if Z1 and Z2 are two complex numbers, then what is real part of Z1 into Z2? They are asking, if Z1 and Z2 are two complex numbers, then real part of Z1 into Z2 equal to. Clear? Okay, for that let us take Z1 as A plus IB and Z2 as C plus ID are two complex numbers. Here real part of Z1 into Z2, RE means real part, IM means imaginary part. Let us see what they are asking. Real part of Z1 into Z2. So real part of Z1 into Z2 equal to, what you are going to have, real part of Z1 into Z2. That means A into C plus I into AD plus I into CD minus B into D. So this is equal to real part of, I can write it as AC minus BD plus I into AD plus CD. That is A into D, AID. Next, this is C into IB. Clear? So that is AD plus CB. You are going to have this term. So now what you are going to have, real part of this is AC minus BD. This is real part of this particular Z1 into Z2. What is A here? A is real part of Z1. Next, what is C here? Real part of Z2. Minus, what is B? Imaginary part of Z1. What is D? Imaginary part of Z2. Clear? So real part of Z1 into Z2 is real part of Z1 into Z2 minus imaginary part of Z1 into Z2. So that's why what you are going to have your answer as none of this. So first time you are getting none of this in my nearly 6 hours of class. Clear? Till now we have not got none of this. Now we are getting none of this as our answer, because if we check real part of Z1 into Z2 minus imaginary part of Z1 into Z2 will be your answer for this particular 8th question. Now let us move for problem number 9. That is, real part of 1 plus I whole square divided by 3 minus I. They are asking the real part of this particular value. Clear? So for that reason, we know that 1 plus I whole square equal to what? 1 I square is minus 1 plus 2I divided by what they have given, 3 minus I. You rationalize it. If you rationalize, 3 square plus 1 square you are going to get into 3 plus I you are going to get. Cancel plus 1 and minus 1. So 3 square is 9. 9 plus 1 you are going to get divided by 10. I into I square, that is minus 1. That means you are going to get minus 2. So 3 minus 2 you are going to get 1. Clear? So that means plus 1 minus 1 cancelled. 2 into 3 you are going to get 6 I into I square minus 1 into 2, that is I into I square minus 1 into 2 is minus 2 you are going to have. So what they are asking, real part of this particular number, what you are going to get, real part minus 2 by 10. What is minus 2 by 10? That is nothing but minus 1 by 5. So this is your answer, minus 1 by 5. Clear? So while calculating be cautious whenever you are solving about I into I square will be -1, -1 into 2 you are going to have -2, 2I into 3 you are going to have 6I, this is imaginary part, this is real part, -2 by 10, so therefore -1 by 5, that is real part of this particular number equal to -2 by 10, that is nothing but -1 by 5. Okay students, now let us solve problem number 9. This will be 1 plus 2I divided by 5 plus 3 minus 3I divided by 4 multiplied with 3 plus 4I divided by 20, 2 plus 4I. I think you know how I am simplifying. You rationalize this, you are going to get this. You rationalize this, you will get this. Again you rationalize this, you are going to get this. Done. Clear? Okay. So now LCM 4 plus, sorry, this is not 4, this will be 2. 2 plus 4I, this is 15 minus 15I divided by 10 multiplied with 3 into 2, 6 plus 12I plus 8I minus 16 divided by 20. Now 2 plus 15, 17, this is minus 11I divided by 10. Next, minus 10 plus 20I divided by 20. So from this you take 10 common, cancel it, 10 into 1, 10 into 2, you are going to cancel 10 into 1, 10 into 2, so it will be remaining with 17 minus 11I divided by 10 minus 1 plus 2I divided by 2. Clear? 17 into minus 1, minus 17 plus 34I plus 11 minus, that is plus 22 divided by 20. 17 into minus 1, minus 17, 17 into 2, 34I minus 11 into minus 1 plus 11I, this is plus 22. 22 minus 17, 5 plus 34 into 11, 45 divided by 20. So that will be 1 by 4 plus 9 by 4I. 1 by 4 plus 9 by 4I. Okay. In this type of problems, my dear students, your calculation must be very quick so that you can is slow. If the simplification is slow, the problem will be taking a lengthy time. Clear? Okay students, now let us discuss the equality of two complex numbers. In any two complex numbers, please remember the imaginary part and imaginary part, the real part of the one number and the real part of the another number has to be same. That means the real part of Z1, the real part of Z2 must be equal. The imaginary part of Z1 and the imaginary part of Z2 must be equal. If you want to say Z1 equal to Z2. So for that reason, if you say that if Z1 equal to Z2, it is directly says that the real part of Z1 and the real part of Z2 are going to be the same, and the imaginary part of Z1, imaginary part of Z2 are going to be the same. So that it says the Z1 and Z2, which are two complex numbers, are going to be equal. Clear? So that is what I am explaining here. Z1 is x1 plus i1, Z2 is x2 plus i2. If I want to say this Z1 is equal to Z2, x1 must be equal to x2 and y1 must be equal to y2. So that is again one remark says that any two complex numbers with inequalities has some no sense type of thing, that is a plus ib lesser than c plus id has no sense. Clear? Depending on this type of statement also, in the exam they are going to ask the question. How can they ask the question? See here, if, clear, then which of the four is correct? That type questions they can ask, because that type of one of the question has been asked in one of the CET. So for that reason I am going to discuss that question in next coming time. Clear? Okay students, now let us move for the next question, that is, if this is true, what they are asking, if a plus ib lesser than c plus id, if and only if, which of these following is correct? If you know the definition of two complex numbers correctly, that means if you know the equality of two complex numbers definition correctly, then you are going to answer this question very quickly. Clear? Two complex numbers are going to be equal if and only if the real part and real part, the imaginary part and imaginary part are going to be equal. But what they are asking here, a plus ib is lesser than c plus id. Previously I was explaining that if this type of things are given, they have no sense because of this imaginary numbers. Clear? So if this has to be with some sense, if I make b equal to d equal to 0, that means the imaginary part of the complex numbers are 0, then it can be says that a is lesser than c. Now that is going to be true. Clear? So if and only if what you have got, b and d are 0, that means imaginary part is 0. This is having no sense just because of iota terms or imaginary terms. If I make that imaginary terms as 0, then this is going to be a is less than c, then it is going to be having a correct form. So now if these two terms are 0, we know that b square plus d square is also 0, because this is 0, this is also 0. b is 0, d is 0, therefore it is obviously giving me an answer as 0. Therefore b square plus d square must be equal to 0. Clear? Okay. Okay students, now let us move for our next topic, that is conjugate of two complex numbers. Here conjugate of two complex numbers means, first let us take one of the complex number, that is, if z equal to a plus ib is my one complex number, then what is the conjugate of this z equal to a plus ib? The definition tells that if z equal to a plus ib is the complex number, then if z equal to a plus ib is complex number, then z bar a minus ib is conjugate. Clear? Is conjugate of z, is conjugate of z, conjugate of a complex number. That is, if z equal to a plus ib, then the conjugate of z is a minus ib. That is, according to the conjugate of any complex number, it says that if you are going to write z equal to a plus ib as one of the complex number, then its conjugate is going to be z bar, that is equal to a minus ib. That is what written here. Conjugate is z bar equal to a minus ib of z, where z is your given complex number. Then let us see what is the geometrical interpretation of this. This is imaginary axis. Next, real axis. If this is a comma b, with theta. So this number is going to be a plus ib. Clear? So now you look at the conjugate. What is it? A minus ib. That means a is positive but b is negative. X coordinate is positive but y coordinate is negative. That means here y coordinate is positive, here it is negative. You are going to have this as z bar, that is equal to a minus ib. Clear? So angle will be with minus theta. Clear? If z equal to a plus ib, z bar is a minus ib. So now this is what your geometrical interpretation of the conjugate of your complex number. Here the remark is conjugate is an image through real axis, that is x axis. Clear? So remark of this particular conjugate tells that if z equal to a plus ib, the definition tells that z bar is equal to a minus ib, which is conjugate of the given number. Then the geometrical interpretation will be like this, where x is always positive but y is going to be negative on imaginary axis. So you are going to have in fourth quadrant z bar, z in first quadrant, z bar is in fourth quadrant. Clear? So now the remark of your conjugate is that the conjugate number of any complex number is going to be the image of the complex number through x axis. Clear? Okay. Now let us move for properties of conjugate numbers. Okay students, if z is complex number plus z bar is the conjugate of the given complex number, then it is going to be 2 times of real part of z. Please remember, a complex number plus the conjugate of the complex number will going to be 2 times of the real part of your complex number. That will be going to be equal to purely real. Second one, z minus z bar is going to be equal to 2 times of imaginary part of z, that is purely imaginary. That is going to be purely imaginary. Third one, z into z bar is going to be equal to mod of z bar square. Mod of z means the length of your complex number from origin, that is square root of x square plus y square. So this is going to be equal to mod of z square. That means if I multiply a complex number with the conjugate of complex number, you are going to have mod of z square, where mod of z means square root of x square plus y square, that is the distance of complex number from its origin. Clear? These are the very important properties, 3 important properties. And now let us move for the next important properties. Next important property is z1 plus z2 whole bar is written as z1 bar plus z2 bar. Fifth one, z1 plus minus z2 can be written as z1 bar minus z2 bar. Sixth one, z1 into z2 can be written as z1 bar into z2 bar. So these are the some important properties of conjugate of any complex number. Now let us move for reciprocal of complex number. Okay students, now let us move for the reciprocal of complex number. that is z to the power of minus 1 is written as 1 by z. Now if I rationalize this, definitely you are going to have a conjugate of z. So that is nothing but multiplying it with z bar and z bar. If I rationalize this number, that is directly you are going to have the conjugate of z and you are multiplying with z bar. So this is going to be the z bar. If I multiply these two terms, mod of z square you are going to have from your properties. Clear? So reciprocal of z can be written as 1 by z. If I multiply with the conjugates, you are going to have z bar by mod of z square. That is nothing but your z to the power of minus 1, that is equal to z bar divided by mod of z square. 1 by z is also nothing but it is equal to what? Mod of, z bar divided by mod of z square. This is what your reciprocal of any complex number. Okay students, now by using the reciprocal of complex numbers, let us go for this problem. Clear? So which is a is 1, b is minus 1, c is 0, d is none of this. So that is here, let us take z inverse to the bar into z bar. This will be equal to what? 1 by z bar into z bar equal to 1. If you solve it in simple manner, it will be like this, which is going to be equal to 1. So now you will have your answer as what? 1. No problem. But let us solve it in another way also. Take z equal to x plus iy, z bar equal to x minus iy, and let us simplify this. We know that z inverse equal to z bar divided by mod of z square by the reciprocal of complex number. Now simplify this, that is z bar mod of z square into z bar. But see here, for your z inverse there is a conjugate, so this will be double conjugate. Clear? If z equal to x plus iy, if you write double conjugate, again it will be the same number, that is x plus iy only divided by what? X square plus y square multiplied with what? Z bar, that means x minus iy. If I multiply these two, again you are going to have x square plus y square divided by x square plus y square. So answer is 1. So this is the proof of this particular problem, but you can simplify in very simple manner like this. So answer will be 1 here also. So you know that if I prove that, again you are going to get answer as 1. Okay students. Now let us move for the next problem, that is z square plus z bar equal to 0. You have to find the number of solutions for z square plus z bar equal to 0. Okay. See, z bar means x minus iy, z means x plus iy. If I take z equal to x plus iy, z bar will be x minus iy. So now try to simplify this, that is x plus iy whole square plus x minus iy equal to 0. A plus b whole square for x square minus y square plus 2i xy plus x minus iy equal to 0. Here this will be minus just because of I square is minus 1. So x square minus y square plus x is your one form. Another one is plus I into what? 2xy minus y equal to 0. So here you are going to have two equations. X square minus y square plus x equal to 0 and 2xy minus y equal to 0. Okay, you take this as equation 1 and this as equation 2. So solving equation 1 and 2, you are going to have the number of solutions. See here, which term is common? Y is common. 2x minus 1 equal to 0. So y equal to 0 and x equal to 1 by 2. This is your first solution, that is y equal to 0 and x equal to 1 by 2. Now use these terms in equation 1. If y equal to 0, this term is 0, what you are going to have? If y equal to 0, x square plus x equal to 0, that is x times of x plus 1 equal to 0. You are going to have x is 0 and x equal to minus 1. See here, x is 0 and x equal to minus 1 if y equal to 0. So that 0 comma if x equal to 0, okay, here if I take x equal to 0 and x equal to minus 1, so that is if x is 0, y is 0. Another one, if x equal to minus 1, y is 0. So you had 3 solutions. Clear? Now let us go for if x equal to 1 by 2. If x equal to 1 by 2, now what you are going to have? If x equal to 1 by 2, you are going to simplify here. If x equal to 1 by 2, if you simplify, again you are going to get a solution. That will be, if x equal to 1 by 2, 1 by 4, here 1 by 4 plus 1 by 2 equal to x square. That will be plus or minus 3 by 4. Plus or minus 3 by 4 for x. So if you calculate, you have how many solutions? Here you have 4 solutions. Clear? 0 comma 1 by 2. Here x, whenever x is 0, y is 0. Whenever x is minus 1, y is 0. Therefore x equal to 1 by 2, you have plus or minus 3 by 4. So totally you have 4 solutions for this particular problem. You again try, one more time you try, so that you are going to get, that is you have 4 solutions for this particular problem. Just simplify that. Z and Z bar you have to take, put in the place of Z and Z bar, you simplify. Here x plus a plus b whole square, I square will be minus 1, again simplify it. So you will have 2 terms, that is 2 equations. Clear? This is real part, this is imaginary part. You solve these 2 equations. Therefore, by simplifying, you will be having 4 solutions for this particular problem. That will be option D. Okay students, see here, if I simplify this, you are going to have 4 solutions. Here 1 by 4 plus 1 by 2 equal to y square. If you take minus y square on that side, it will be plus y square. So y will be plus or minus 3 by 4 for x equal to 1 by 2. For x equal to 1 by 2, you had 0. This was first solution. First solution. Here you have 2 and this is 4. So therefore totally you are going to have 4 number of solutions. If you want it, again you can simplify clearly and you can think that is it is having 4 number of solutions. Okay students, now let us move for our next problem, that is the conjugate of 2 plus I whole square divided by 3 plus I. So you know what is conjugate. If z equal to a plus ib, z bar will be equal to a minus ib. That is what your conjugate. So now let us try to find the conjugate of this particular number. So that is 2 plus I whole square will be what? 4 minus 1 plus 2i divided by what? You simplify this, that is 9 plus 1 into 3 minus I you are going to have by rationalizing this. Clear? I am not writing each and everything. If I expand this, 4 minus 1 plus 4i you are going to have. Next, divided by, if I rationalize this, you are going to have here 9 plus 1, here 3 minus I. 9 plus 1 is what? 10. 4 minus 1 is what? 3. So 3 plus 4i multiplied with 3 minus I divided by 10. Again simplify. 3 into 3, 9 minus 3i plus 12i. I square is minus 1, minus into minus plus 1. Therefore, this is plus 4 divided by 10. 9 plus 4, it will be 13 plus 9i divided by 10. See, 9 plus 4, 13, minus 3i plus 12i will be 9i divided by 10. So you got 13 plus 9i divided by 10. I think you got the solution of this particular problem. Now what can you tell the answer? 13 plus 9i divided by 10. Option what? Option D. Is it correct? Check once. Already you got 13 plus 9i divided by 10. Are you taking option D as your answer or not? Because, why I am asking like this? Because they are asking conjugate. They are asking conjugate. Then conjugate of this will be what? Conjugate of this will be 13 minus 9i divided by 10. So don't make hurry while solving the problems. 13 minus 9i divided by 10 is your answer, means what? 13 by 10. This is minus. So that's why option C is your answer. In this type of problems, they are going to be very simple. Where they are very simple, you will make in a hurry to solve the problem and you will go for option D. But that is very wrong thing. Don't make hurry in exam. If the problem is simple, no worry, solve it very slowly. That means working must be the fast. But while answering the question, while putting the answer in your answer sheet, don't make hurry. Think once more and you put the answer in your answer sheet. So here option C is the correct answer. Clear?